Murli sir will start by 10:20. Murli Mohan Raju sir.
Yes, sir. Sure, sir.
So please start things by 10:20.
Yeah.
Principal madam is busy and chairman sir is also busy with vice principal because autonomous exams have started today.
Okay.
So in their absence, you please call them. Madam said
Okay,
she will join you back within another 15 minutes.
Okay, sir. Sure, sir.
The time madam joins, please try to call back madam again.
చేంజ్ సార్
Sure,
అది
sir.
వస్తలేదు మళ్ళీ చేంజ్ చేసిన
Yes.
అది పంపిస్తాను అందరికి ఇప్పుడు మళ్ళీ పంపించండి నేను కూడా పంపించేస్తాను వాట్సాప్ క్రియేట్ అయిందా ఈ లింక్ ఈ వాట్సాప్ ఈ యూట్యూబ్ లింక్ పెట్టండి అంతా ఇప్పుడు పంపించిన యూట్యూబ్ లింక్ పెట్టండి సార్
Yes, sir, please start.
Am I audible, sir?
Yes, sir, you are audible, sir. Request CVGK Rao sir to come on video mode.
Sir, I am ready, sir. I am here.
Yes, sir.
A very good morning to one and all. Myself, T. Murali Mohan Raju, Assistant Professor in the Department of Automobile Engineering. I take the privilege of presenting the welcome address for this 1 week workshop, national level workshop on innovative methods in finite element analysis using ANSYS and ABAQUS, FE3A 2022. And this is scheduled from 21st March 2022 to 25th March 2022. It gives me immense pleasure in welcoming you all for this 1 week workshop. I take the pleasure of welcoming our honorable management members, Dr. K.P. Srinivasarao Garu, Chairman, M. Krishna Kumar Garu, Secretary, Maturi Educational Society, Jupudi Sudhakar Garu, Treasurer, Maturi Educational Society. We welcome you all, sir, for this 1 week workshop. It gives me immense pleasure in welcoming our dynamic administrators, Dr. G. Kanakadurga Garu, Principal, MVSR Engineering College, for this 5-day workshop. Welcome you, madam. I now welcome our dynamic Vice Principal, Professor S.G.S. Murthy Garu, for this program. Welcome you, sir. I take the privilege of welcoming our partnering Institute of Innovation Council's President, Professor C.V. Gopal Krishna Rao Garu, for this 1 week national level workshop. Welcome you, sir. I welcome the convener of this 1 week workshop, Dr. G. Srinivas Sharma Garu, Head of Automobile Engineering Department, for this 1 week national level workshop. Welcome you, sir. I take the privilege of welcoming all the faculty members, students of different engineering colleges for this workshop. We welcome you all, sir, for this 1 week workshop and being a part of this workshop. Last but not the least, I take the privilege of welcoming our today's program, with the crash analyst, Satyam Ventures. Welcome you, sir, for this program. Dr. P. Anil Kumar, Scientist of Research Center, Imarat. He is here with us for this inaugural session. Thank you, sir. Thank you for being with us. We welcome you, sir. And I thank the convener of this program, Dr. G. Srinivas Sharma Garu, for giving me this opportunity to present this welcome address. I now request Dr. G. Srinivas Sharma Garu to kindly take over the program. Thank you, sir. Thank you very much, sir.
Thank you, Murli. I request Vijay, Assistant Professor in the Department of Automobile Engineering, to go for virtual lighting of lamp. Vijay?
Oh, okay, sir. Okay, sir.
Yes.
वक्रतुण्ड महाकाय सूर्यकोटि समप्रभा निर्विघ्नं कुरु मे देव सर्वकार्येषु सर्वदा.
Thank you, Vijay. That was a wonderful virtual lighting of lamp. Respected Dr. K.P. Srinivasarao, Chairman, Maturi Education Society in absence. Respected Krishna Kumar Garu, Secretary of Maturi Education Society. Respected Jupudi Sudhakar Garu, Honorable Treasurer of Maturi Education Society. Principal, Madam Dr. G. Kanakadurga Garu, Vice Principal of MVSR Engineering College, Professor S.J.S. Murthy Garu, all heads of the departments, respected participants, and the coordinators of this 1 week national level workshop on innovative methods in finite element analysis using ANSYS and ABAQUS, M. Vijay and Bhagwan Malik Sab Bhagwan Garu, and all my colleagues, distinguished participants from various engineering colleges, diploma students from various polytechnic colleges, and the most dynamic students, most enthusiastic, energetic students from Department of Automobile Engineering, MVSR Engineering College. I welcome you all to this 1 week national level innovative workshop on finite element analysis using ANSYS and ABAQUS, which is a value added course as well as a certified course. This particular course is having a lot of prominence in the industry, wherein the people working in cyberspaces, people who are looking at innovative methods in computer applications, machine learning, artificial intelligences, are working on actual physical systems. They're actually working on the physical systems, especially automobiles, and this particular workshop will give a clear, very clear, inquisite and insight into the developments of the engineering applications in automobiles. We have totally planned this for around a week, complete week, wherein day one session will be taken care. Day one session will be taken care by very eminent people from industry. We have Professor Devendra Kumar Peruri from Sachem Ventures, who's a crash analyst engineer, who has already have an experience working with IIT Delhi, a known person working in the prime areas on accident data analysis, reconstruction of accidents, and injury evaluations. This is the topic of latest trend, wherein it helps not only just automobile engineering industry, but also this is social cause. The second session is taken care by the eminent scientist from DRD, from one of the labs of defense organizations, RCI, Research Center Imarat, Dr. P. Anil Kumar, who is scientist F, and his topics are on applications of ANSYS in automotive components. Day 2, we have the talk from finite element applications in metal forming by Dr. J. Kandaswamy, Professor, Department of Mechanical Engineering, MESREC. Then 11:30 to 1 and 2 to 4, the two particular sessions are taken care by EDS Technologies, who have come out with an MOU with MVSR in partnering the technologies pertaining to ABAQUS. And the Department of Automobile Engineering has recently procured ABAQUS software, and we are in the process of developing solutions to the industry in association with EDS Technologies. So it is one particular aspect where we are trying to go into the consultancy aspects apart from regular academic excellences. And for this, the student should be trained at all levels. Hence, we took up this particular analysis, static analysis and dynamic analysis, which also includes modal analysis, TORSA. Then 23rd, we have human body CAE modeling and analysis by Ashok Kumar Salaimuthu, crash engineer from Sachem Ventures. This is one particular topic wherein there's a lot of effort has been kept from Toyota Corporation in trying to model human body. Earlier, they used to take toys or a human model made of some polymer, and then they used to keep it in the crash testing, and then they used to test it, but that would not really exactly give what order of crash is happening and damage to the human bodies. Hence, this particular human body CAE modeling and analysis is again state of art. Then we have 2 to 4 on day 3, finite element analysis using ANSYS by Lokavarapu Bhaskar Rao, professor from Department of Mechanical Engineering, VIT Kumbakonam. 24th, we have CFD analysis using ANSYS Fluents by Dr. M. Vishnu Teja, professor from IIT Dhanbad. Followed by the session by Karthik Rajshekhar, assistant professor in Department of Mechanical Engineering and also research scholar from BITS Hyderabad, on finite element techniques applicable to nanocomposite materials. 25th, the session is pertaining to numerical analysis on automobile components developed using fiber reinforced composites by Dr. M. Madhavi, professor and head Department of Mechanical Engineering, MVSR Engineering College. 2 to 4 p.m. on the last day, fluid dynamics and aerodynamics over high-speed automobiles using ANSYS fluents and some applications pertaining to computational fluid dynamics specific to automobiles has been taken up by Dr. G.S. Sharma, Head Department of Automobile Engineering. The topics are very versatile. The people who have been drafted onto this particular aspects are well expertised in the areas of automobile engineering. This is about the conference. This is about the workshop, which we have drafted it for one particular week in association with Institution Innovation Council under Self-Driven Activity Scheme. Now, as a head department of automobile engineering, I would like to present and submit the following to the august audience about the department. The Department of Automobile Engineering was established 12 years back with the in-house of mechanical engineering, where mechanical engineering department is existing right from inception. MVSR Engineering College have started mechanical department in 1981, and a Department of Automobile Engineering is around 12 years old. And we have complete facilities, in-house testing, automobile equipment pertaining to automobile engineering. This year, we are autonomous and we have changed our syllabus tangentially from the AICT model curriculum, wherein we have introduced foreign languages like German. We have introduced new labs like new component development and prototyping testing. We have introduced computer-aided manufacturing. We are in the process of developing 3D printing. We are in the process of additive manufacturing technologies, because automobile engineering is not just one particular component of scientificness. Rather, it is also dealing with mobility as well as it is dealing with the safety aspects of it. So the Department of Automobile Engineering as on now is totally having 168 students, 168 students across all the 3 particular years. And we have our proud alumni placed in companies like Tesla. They are in Ford, they are in Mahindra, they are in very, very good companies. They are in Infosys, they are in Cognizant, they are in every particular part. And this year, out of 75 final year students, we could successfully place around 52 students in the placements of it. But still there is a big void, and this industry institute interaction will try to give more edge to the students and will take us forward. So with this very brief note, I would like to conclude my introductory comments and request Professor C.V.G.K. Rao, C. Venkat Gopal Krishna Rao, Head Department of Electrical Engineering, and also the President of Institute Innovation Council, to please give his talk. Thank you.
Thank you, Dr. Sharma Garu. Thank you very much. Respected Honorable Management Members, Principal, Vice Principal, other head of the departments, my dear colleagues, as well as dear participants, A very good morning and welcome to all of you for this 1 week innovative methods in finite element analysis using ANSYS and ABAQUS. I must thank Dr. Sharma Garu for having selected an excellent topic. I say it is an excellent topic for the two reasons. Number one, it is not only useful for your present academics, but also from our Institution Innovation Council, who are expecting an outcome of innovativeness after this workshop. Because having gone through the scope of this 1 week workshop, the department is going to provide an in-depth knowledge not only about the fundamentals of finite element methods, but also the other what is called as the research aspects as well as innovative views of finite element methods. So therefore, it is very natural for our IISc, that is our selfishness, to expect an outcome, an excellent outcome towards contribution of our IISc cell. We in IISc cell of MVSR Engineering College, in brief, our aim is to create the awareness as well as to provide the requirements and sufficient training for the students, and of course as well as we also train the staff to come up with the innovative methods. The students who come out with innovative methods and innovative practices, we will also show them a way for the startups also. And last year we have concentrated in creating the awareness of about this IISc cell, and we moved with the help of all our team members of IISc. We could contribute certain aspects or certain angles of IISc. Now, with the involvement of more of this sort of workshops, we hope we'll do still better, and we are aiming to what is called as go for some sort of collaborations and patents with the other industries also. I hope this sort of workshops will pave the way towards that particular aim. And also I must thank all the industry as well as academic experts who have readily accepted as resource persons for this 1 day workshop. I hope all the students please kindly make use of this 1 day workshop on the finite element methods, because finite element methods will give you a scope to concentrate on a particular portion of a large area also, if I know something. Because in our electrical engineering also we apply finite element methods to have a differential insulation levels of a structure, and our electric field strengths and potentials have got some analogous quantities with your mechanical engineering as well. And here in electrical engineering also, with the finite element methods, a lot of innovations are going on to reduce the cost and make effective use of the composite materials, etc. A similar sort of things I hope in mechanical engineering is also going around. And definitely, once again, I'm stressing that after this, what is called as 1 day, we, instead of simply ending up with a certificate, I hope at least some innovations will definitely come, and they will be contributed towards a big way in the what is called as a startups also. I wish this particularly from our mechanical and automobile engineering students. I thank one and all for having given me this opportunity. I wish you a very good luck to all of you. Once again, congratulations to Dr. Sharma and his team for selecting an excellent topic. Thank you very much, sir. Thank you.
Thank you, sir. I would now request Devendra Kumar, sir. Sir, Devendra Kumar, sir. I think Devendra Kumar, sir, has joined. I think sir would be ready for his 11 o'clock lecture. I believe so. So, this is about the workshop. In fact, today autonomous examinations have been started. The college was accredited autonomous status this year, and today for first years the complete autonomous examinations have started. Hence, the principal and vice principal are quite busy taking up the precautionary measures in conducting the examination. So, in their absence, I would definitely appreciate. In their absence, I'll appreciate about the MVSR Engineering College. MVSR Engineering College is established in the year 1981, sponsored by MATURI Education Society. Right now, we have totally 7 particular departments. We have automobile engineering department, mechanical engineering department, civil engineering department, computer science engineering department, information technology department, electronics and communication engineering department, and a very vibrant department is our electrical and electronics AAA department. With the freshman's course, that is applied sciences and humanities department, wherein it has completely department of mathematics, department of physics, department of chemistry, department of English, department of commerce, and the allied courses. The college is accredited with NBA 4 times. The courses, various courses were accredited with NBA for multiple number of times. We are NAC accredited. We are ISO 9001 2015 certified institution. We are the only institution internationally certified with ISO on educational standards. We are NIRF ranked institution, and we in AICT, IIC, in Institution Innovation Council, we are ranking above 4-star. All due credits to Professor CBGK Rao. The college has acquired autonomous status this particular year, and there are about 250 teaching faculty with around 179 supporting faculties. The campus is completely, lush green of 18.5 acres at Nadargul, and the college is very vibrant. We believe education is right for everyone, and in doing so, the college is contributing every inch in the national development. So these are the remarks. In between, if principal madam joins, I'll try to see to it. Madam also talks about this. So now I request Vijay to give vote of thanks.
Good morning, one and all. Sir, am I audible?
Yes, you're audible, Vijay.
Okay, sir. Thank you, sir. So, first of all, I would like to welcome all the participants for this 1 week national level certified workshop on innovative methods in the finite element analysis using the ANSYS and ABAQUS. I would like to thank the chairman, Maharashtra Education Society, Dr. K.P. Srinivasrao sir, principal madam, Dr. G. Kanakadurga, management members, head of the department automobile engineering, Dr. G. Srinivas Sharma, president IIC, MVSR, CVG Gopalakrishna sir. So for encouraging us to provide this 1 week workshop for the students and enhance their knowledge in the field of the finite element analysis. And I will also like to thank the participants for showing the immense interest and participating in a huge numbers and making the workshop a grand success. Thank you one and all, and I wish the participants a great learning. Thank you.
Thank you, Vijay. And one particular point of instruction to every participant in this particular student community is to carefully follow up the procedures as well as the ideas that would be thrown by the distinguished resource persons, because we have drafted the resource persons from the industry as well as from the institution, because industry and institute cannot cannot diverge. They have to converge, and this is one particular point of time where convergence is expected to be on board. So I request all the students to see to it they utilize this particular point of time. Attendance is mandatory because we made it as a CAE internship certificate also. So those who are trying to claim CAE internship certificate, they have to attend all the particular sessions. That is a mandatory thing for claiming your internship certificate. And the workshops, we have hands-on experience, we have thoughts, we have ideas, we have implementation, we have whatnot, everything we have it on board. So just wait till our resource person, Dr. Devendra Kumar Peruri, will join us. I've seen sir joining us on link, but hopefully the time is around 11, so I believe sir would be joining by 11. But in the meanwhile, I request everybody to see to it they take out some notes and follow up all the things. And we will also post the complete recordings of this to all the registered participants. Thank you very much. Vijay sir,
Yes, sir.
please let me know when Devendra Kumar sir joins,
Okay, okay, sir.
because I want to give sir's introduction profile.
Okay, sir. Sir, call is sir immediately. No, no, no. Vamos a ver si mi camera bien. ఇంకో నెంబర్ వచ్చి వాళ్ళు చేస్తే వాళ్ళ మేడం వెళ్తుంది ఇంకో నెంబర్ వచ్చింది దాని మీద
I request all the participants to be online. The sir has scheduled the meeting by 11. Automatically, he will join by 11. So, request all the participants to be online. Vijay, I'm trying to reach sir. If sir joins, immediately give introduction. I'll join you back. 2 minutes.
Okay, sir.
I have just now received message, Vijay. Like sir is facing some technical problem, it seems. So I'll wait another 5 minutes.
Okay, sir. Okay, sir.
Yeah.
Hello, Devendra Kumar sir. Is my voice audible?
Hello.
Hello, sir. Am I audible to you?
Yeah, I'm audible, sir.
Yeah. Okay, okay, sir. One second, sir. I will start the session.
Yeah, is this mode is okay, or can I join in presenter mode?
You can also present, sir. Not an issue. You are able to share your screen, right? Yes, right, sir.
Uh, yeah, present.
Yes.
I can.
One second, sir.
Yeah.
Sir, join us, sir. Yes, sir. మీ ఇష్టం సార్ ఎట్లా ఓకే ఓకే సార్ ఓకే సార్ ఎస్ ఓకే సార్ ఓకే సార్ చెప్పండి సార్
Good morning, Devendra Kumar sir.
Yeah, good morning, sir.
I'm sorry I was bothering you by calling you up.
Yeah, no problem.
Dear participants, I would take the privilege of introducing our highly valuable resource person, Devendra
sir.
Kumar Peruri from
ఓకే సార్
Sachem Benches.
అవును సార్
Sir, MVSR Engineering College, welcome you aboard
ఎస్ సార్ ఎస్ సార్
Yeah,
to this workshop, sir.
Thank
We
you.
are we are highly honored today to have you on board. I would like to put up
ఇష్టం సార్ మరి
Devendra Kumar Peruri, Assistant Project Manager Safety's very brief profile. It is something like a drop in an ocean because the time I was looking out the works, they were immense. Devendra Kumar P is Assistant Project Manager at Sachem Ventures Engineering Services Private Limited, responsible for the following crash safety areas: analysis of US NH TSA, NASS, CDS is the data pertaining to accidents, and China accident data systems, accident databases, accident reconstruction of critical cases in US database, root cause analysis of car-to-car simulation including test correlations, process automation of crash safety works using VBA, JavaScript, Python languages, material characterizations and test correlations of GFRP, CFRP composites, value addition through AI and ML initiatives across teams, human body modeling and impact biomechanics. Totally 17 years of experience, including CA analysis, road accidents, reconstruction, data collection. Worked for 8 years as project associate at IIT Delhi. This is definitely a very catchy thing where industry and academic are completely gapped up. Then Master of Science in Research from IIT Delhi. Sir, I know this is only a drop in the ocean of your knowledge because the time would be very less for us to talk about all your things. This is what
Yeah.
Srinivas Reddy was sharing to me the other day. So I would request you to be on board and please try to enlighten our students because this is a very versatile group, sir, wherein we have students from final years and third years, and we have faculty across all over India, which has been YouTube live streamed, and they are watching it. The next 1 hour is for you, sir. Thank you very much.
Yeah, thank you very much, sir. Uh, Good morning to all of you. I hope I am audible clearly.
Yes, sir. You are audible, sir.
Yeah.
Yeah, hope my screen is visible to everyone. Is it okay?
Okay, sir, it is visible.
Yes, sir. Yeah, thank you. So today I will go through the next 1 hour is on mainly what is the application of CI in automotive industry, and majorly what will apply where this CI in automotive industries. Actually, CI can apply in anywhere, but specifically for automobile engineers and mechanical engineers. So this is a very high scope in the automotive industry. Yeah, where generally CI will apply in the automotive industry. So in the conventional development process, not only automobile and any product, so we have some idea about the complete outline of a vehicle or any product. So that we will call it as a plan. So according to our view or our plan, we will design something, right? Yeah, we will design our product, right? In our case, it is automobile and car. So we will design some idea, whether it might be sedan or it may be the hatchback or something like that. So we will manufacture it. So according to our design conditions, whether which load is taking or whatever the parameters, whatever the loading conditions, according to that we will design as per our engineering knowledge. So we will design our product and we will manufacturing it, and we will check before the production it. So one prototype we will produce, and we will check for the whether everything is okay or not. So according to our design procedure, it was there or not, we will evaluate and we will predict it. Means in this evaluation, mostly we will get the our design process might be the failure. So we will go to the iterative cycles to again we will change our design parameters, and again prototype we have to manufacturing it, and again we have to evaluate. So to avoid these iterative cycles, so we will introduce the CI. So computer applications in engineering, right? So after the designing, without produce that prototype, if you are checking the CI, that is in the virtual mode, if you are check the our design process is correct or not, so we can avoid this prototype, and again testing, physical testing, all these things we can avoid it. So that is where that CI will come into the picture of in any product line. So not only in this, in our case it is automobile, right? So there it is in the CI. So we can avoid the prototype, that means physical manufacturing of the our product, right? So this is where we will apply the CI. The major CI applications in automobile is like in engineering departments, we can divide these things as crash worthiness of vehicle. That means if it is any accidents or in any crash, our vehicle is safer or not for the occupant or pedestrian or whatever human beings. So that we will call it as a crash worthiness of the vehicle. So our vehicle should be withstand for any accidents or any loadings, external loads when it came. So if suddenly some big object is dropped down from the on the car, it should be withstand like that. Any crash worthiness, it should be withstand. And similarly, noise, vibration, and harshness. So we'll design our vehicle without any noise and vibrations. If you are riding in a car, it should be very comfortable to riders, right? Or who are journeying in the car. So this is also be very crucial. In this area also we'll apply our CI applications. And obviously strength and durability. So any product we will apply this strength and durability analysis. And finally the drivability. So from the suspension point of view and the tire force point of view, we will apply these CI applications. So this multi-body dynamic analysis we will do in the drivability part. From the where it was the mass loadings and everything will come. So today I will explain only about the crash worthiness, that means vehicle safety, as I have more knowledge on the crash safety analysis. So I will cover about the crash worthiness of the vehicle safety, where the CAE will apply, can apply in use, right? So am I audible clearly? Just confirmation.
Yes, sir. Yes, sir. You're
Yes,
audible
sir.
clearly.
Yeah, thank you. Yeah, thank you. Yeah, as it's virtual, I have to confirm in between. If I lost something, please let me know. Thank you. So coming to the crash worthiness of vehicle, why we will do for the this crash analysis of the car? So I think most of us think nothing is important more than a life, right? I think 99% of audience can agree with my statement. So if this life is gone based upon so many reasons, and one of that is the road accidents. So most of us think about this road accidents will be the occur due to the some fate of riders or something. If you are very unfortunate, we will get the road accidents, and something destiny will decide road accidents, and always we will think that the road accident will not occur to me and it will occur to others. So, but not it is not the unfortunate thing. So, as researchers and engineers decide that all the road accidents not about the not only because of the unfortunate things. So, on the road accidents, so many lives will go on. So, for me, it is very as I came across the so much of database of the road accidents, it is very crucial uh, uh, for a human being to save a life. So why it will happen? If it is not only as unfortunate thing, and if it is not an accident, generally when we call it as an accident means only it is unfortunate, then only we'll call it as accident. But so many accidents will occur due to the negligence of the riders and vehicle designs and the road infrastructures. These are the three main parameters to occur the road accidents. So 60% of the road accidents will occur, more than 60% is the riders that means riders concentrations or what we can call negligence. So if you are very conscious about when you are ride a vehicle or car or whatever it may be on the road, so we can avoid 60% of the road accidents. So definitely you have to concentrate and conscious when you are riding. So that is the major contribution of the road accident is the drivers. But as engineers, we have to think about the remaining 40%. So as a human being, definitely we have to more concentrate and conscious about the road accidents. As an engineer, we have to concentrate the other part, the remaining 40% of the road accidents, which will how we can save a life in a road accidents. So even if it is occur, that is we can call it as a passive safety. So another point next is, can we prevent these road accidents really? So because even human negligence or road infrastructure is not good, and if it is any vehicle fault, it is there. So can we prevent the road accidents? That is the main question. So the answer is, can we save the life or road accidents? So if you are not able to prevent a road accident, at least can we save a life in a road accidents? These are the two major questions will challenge us the engineers, vehicle engineers. So the answer is yes, we can. There are some proofs also be it is there. We can reduce the accidents and we can save the lives in accidents. So if you take as one example, or the country, developed country, we can call it as a Japan. So these are the statistics of the Japan. In the 1990, there are fatalities. When we call it as fatality means in any road accidents, if any death is occurred, then we will call it as a fatality. So in 1990, so there are 15,000 fatalities occurred. So please think this is not an accident. These are only fatalities. 15,000 fatalities occur. So according to their developments and do the data analysis and vehicle improvements and road infrastructure development and the drivers awareness programs, all those things they implemented and they brought reduced to the 5,000 fatalities in 2015. And in 2020, they have brought it less than 3,000, and their target is the zero fatalities by 2030. So, can you imagine if anyone knows about what are the fatalities in India? So, it is the 10 times more than the Japan. That means only fatalities is around 1,50,000, even in 2022 also. So as the statistics up to the 2020 we have, so it is 1,50,000 from the last 5 years. It is not reduced at any cost. So if you see the statistics, compare the statistics of the Japan and India, so it is 10 times more. That means if they brought 15,000 to the zero, they took the 40 years. That means if it 10 times, even we are applying now, it may take the 400 years. So can you imagine? So that is the situation in India, how to reduce the fatalities. Okay, anyway, so but we can do it. So we can have the proofs of the so many countries how they will approach to reduce their accidents and the fatalities. So their target is no fatalities by road accident by 2030. So hope we have to apply the so many methodologies are there. Researchers are working on those things. From our part of view, we have to be more conscious and more concentrate while we are driving. So then we can reduce the most of the accidents. So by the way, some statistical number of accidents is around 5 lakhs, but fatalities are the 1,50,000. So this is the statistics of the India. So okay, how to reach to with no fatalities on road? So even in India or any country. So there are two steps are there. One is the understand the accident scenarios. So how these accidents will occur and how to reduce it, right? If you have any problem, first we have to know that how it will happen, what is the root cause of those accidents, all those things. So for that we need an accident database that is called as how the real accidents is occur. So if you have the database, then we can analyze it and what is the root cause, we can extract it and we can apply accordingly. So accident data analysis is nothing but that whatever the database we have, that database we will analyze it and we can draw the required conclusions or required solutions. So that is called accident data analysis. As this database is so I am here in this slide, I am introducing about the US database because that is the most sophisticated database from the long ago. They are started to collect this database. Even in India also we have these databases availability with the central government. They are collecting from the last 20 years. So till now they collected by the police and the traffic people. So from them we have collected in IIT Delhi. So also we have tried to make some database kind of things. So I worked about 10 years to collect how they will collect the accident data and all those things. So anyway, here I'm explaining about what is the database and what are the parameters available on the accident databases. So for each accident, they will collect the around 300 to 400 details of the each one accident. So this data, once we collect all the details, even the minute details, so then we can analyze those details, and we can suggest to the government or vehicle manufacturers, or to give the awareness to the vehicle drivers, and like that. So accident records, when it will occur, which day it is occurred, and all those things, it will be there. Are because of the time restrictions, I am going a little bit fast. But these are the around 300 to 400 details, minute details, it will be there. So, and which day and which hour and how much traffic it is there on the road at the time of the accident, and each 1 hour how many vehicles will go pass through in that particular road. So all those details will be available. And in the event record means how that event is occurred and which vehicle came and when it is manufactured and how old that vehicle is there and who are the drivers and how their driver ages, and all those things will matters. We will think that why it is required the 300 to 400 details for each accidents. So, but it is definitely it is required according to the human psychology. Also, they will analyze how the driver's behavior will be on the roads when they are ride on the national highways, how their behavior is there, and when they are in the cities, how their behavior is there. All each and every minute details is required to reduce the accidents and fatalities. So, and the vehicle records, and as I told, the complete vehicle details. So whether any previous accidents occurred on the same vehicle or any scratches, all those details they will collect it, and exterior vehicle record and interior vehicle record. And in the interior vehicle record, it will be there how much seat belt is available are there, or they used it or not, and airbags are availability and their uses. And the exterior vehicle record is the after accident how much deformation, that means how much vehicle was went inside and all those details, completely length, height, how much vary it was there. According to that, they will consider the severity of the accident and all those things, where that occupant, where it was hit, and injury locations and the speeds of the vehicle, they will assume it. And they will, after that, they will interview the drivers and what are the how the other vehicle came and what is the situation at the time of the accident, all those details. So these details not only they will collect in the 1 hour of the span of the time, they will take the 2 to 3 months, they will follow up and they will complete the things. That's why they completely collect the database. So they will release after 2 to 3 years, the complete database will ready. So sometimes 1 year also it will goes. So after collecting this database, so we will select some variables and combination of variable to analyze according to the problem, right? For the vehicle manufacturers, they will take it the vehicle records and those things. For the policy makers like governments, they will look about the accident records and how the event was there. That means to develop the infrastructure and road infrastructure, any faults are there, those things. So database, if it is available, in all aspects they can use it. So these are the NHT, SCA, NASS and CDS are the departments who are the collect the US database. So, and these selected variables and combination of variables to analyze it. So they will analyze in the pie charts and 2D bar charts, line charts, all those things I will cover in the next slide. So as per the database, we can necessarily whatever the suggestions can give to the improve the regulation standards and both vehicle and the road. So this road infrastructure suggestions we can give it to the government, and for the vehicle manufacturers, can you improve any vehicle point of view to improve the vehicle crash worthiness. So some of the variables, how they will analyze it, I have mentioned in this slide. So how whether this collision is frontal, side, rollover, or rear impacts. So which accident types it was there. So here we will collectively in a particular 1 year how much what type of the collisions are occurring, and if you are particularly taken on one road and what type of the collisions is occurring. So like that they will analyze the accident type and all those things, and what are the speeds and change in velocities from the point of impact to the rest positions and which angle it was there. So all those things we can analyze using the pie charts and bar charts and normal distribution curves, and for the injury risk curves, all those things. Vehicle make and model year also be sometimes it will play a crucial role in these things. If you are using the very old vehicles and the condition of the vehicles will be the problem, and applying the brakes will take the time, and sometimes the brake values they will call it as. So all those things can minutely analyze it. So how it is only one vehicle is occurred and car to car is occurred, and according to the human age, gender, height, weight also be, it depends the how much injury they, for the same severity of the accidents based upon these human parameters, they will get the more injuries, right? If you for a pregnant ladies and for the younger people and older people, they will get the different injuries for the same severity of the accidents. So that time also it is if you are analyzing your database in that direction, it will take. So seat position and occupant postures and seat belt and airbag usages, even availability in the car, but most of the people they may not use it. If it is uses, can we reduce that injury or not? According to that, we will aware the people like that. So which body region gives the more fatalities? So if they occur to the chest kind of things, ribs failures will occur like that. So each and every parameter is important, as I told you. So these MIS, AS are the terminology of the biomechanics. That means abbreviated injury skill, means our injury severity. Like in a vehicle, the deformation, how you will calculate it. Similarly, for the human person, how much severity is there, they will call it as a abbreviated injury scale from 1 to 6. If it is a 6, human will die like that. More than 3, that means 4, 5, 6. Mostly occur, the death will occur for the AS 4, 5, 6. And remaining 1 and 2 will be the less injuries. They can survive with the injuries only. If it is a 0, it will be the no injuries are there. Like that, some from the injuries point of view also we can analyze the accidents. So finally, what is the conclusion of this statistical analysis? We will call it as this type of the data analysis. Everything we will call it as a static analysis. Statistically, we will analyze the data. So here we will mainly conclude what is the role of vehicle in that particular accidents or accident, and what is their driver's role and road users and the road infrastructure roles, and where the environment role also be placed, because in the winter because of the fogs also be so much of accident will occur, specifically like Delhi kind of the cities, it will occur in the winter. So their environment also plays a role. So if that is the cause, we will suggest to the government that what are the necessary actions to be taken to avoid those accidents kind of things, and evaluate the event of road accidents. So to get these, what is the role and how much severity it was there, then only we can work further to reduce the accidents and fatalities. So this is the called statistical analysis. So in SATWIN, we have done for the two major databases, US and China databases. So where it is a two large car markets. So we have identified the main problem of the road safety based upon the real accidents, and from the so due to the confidentiality data, these pictures are the only just taken from the internet and they kept it. So we checked for the senior citizens in the Japan kind of things. Most senior citizens are available. So for them, what are the injuries will occur? So we have done for the US and China database. So we gave the statistical details like how the trends are there and the risk levels. Each accident, critical accident, what are the risk levels? According to the that we can update the next safer car. We can manufacture it, right? So based upon this statistical data analysis, uh, some crash regulations were came even in Europe, United Nations, US, China, now even in India. In the last 2018, they are doing the NCAP tests also. So based upon this statistical data analysis, some regulations, that means any car manufacturers, if they want to release any car in a particular country, they have to follow their country rules. That is the compulsory by the government of the law. So they have each and every part like instrument panel, side windows, interior roofs, and frontal impacts. What are the requirements? So that these are the minimum safety requirements to pass. Then only they can release their car in their market. So for the US, they have the different regulations. For the China, they have the different regulations. For India, different regulations. So to release any car manufacturer their car, these regulations should be passed. So for the each parts and the frontal impacts, there are so many regulations. You can see the numbers, all those things. So I am not going through in details. So each regulations, if you are typing on the internet, you will get it. What are the regulations passed, should be passed, and all those things. So some of the frontal impact, that means if it is vehicle is hit in the frontal head-on collisions, these are the some regulations should be passed. So definitely these should be passed. Then only that vehicle will be introduced in the market. And next one is the NCAP. That means a new car assessment program. It will call. This is done by the vehicle manufacturer itself. They will sell their car to attract the customers. We have the safety star ratings. We can call that some nowadays the Tata people, they are telling that 5-star rating we have the cars like that. So they can sell their car to attract the consumers. They will so this is the more than the standards. That means it's more safer than the previous regulation is the compulsory thing, but NCAP is the vehicle manufacturers. They will comparatively for the competitors, so they will improve the safety and they will attract the people, and that is good for the people, right? So like that, we have each country have the different NCAPs: US NCAP, Japan NCAP, Euro NCAP, Korea, China, Latin. So whichever country, if you want to sell your car, those NCAP ratings they will test for the different conditions. So these targets will be the more stringent than the regulations. So that is the point we have to note it down. So what is the difference between star ratings and the regulations? So particular scenarios, configurations, complete full vehicle, full overlap scenario impact, and ODP scenarios, and side impact, and whiplash impacts, all those things. So they will, if they pass this much of targets, you will get this much of rating. So usually this is 0 to 208 points if you will get the 5-star rating. If If it is more than, if it is completely above 170 or 180 points, you will get the 4-star rating. Above 170 points, you will get the 5-star rating. So these ratings will be different for the different NCAPs. So here I presented, I think, the Japan NCAP I given. So for the collision safety, they will give the 100 points. For the pedestrian safety, they will give the 100 points, like that. If seat belts and all those things, some 8 points will be there. So overall, combinedly, they will check the whether it is more than 170 points are there or not. So these regulations, but even in the pedestrian case also it will be there. So not only inside the car, outside the car also they will check for the star ratings kind of things, right? Head impacts, leg impacts, all those things. So I hope I'm not going very fast, right? So I want to confirm whether I am audible clearly or not.
Yes, sir, you're audible, sir, and there is more, we are more focused on whatever topic you're telling it. Thank you very much. Please continue, sir.
Yeah, thank you so much. So we have the regulations and we have the NCAP tests and all those things. Still, there is a very big gap between the real accidents and these tests, right? If you think that complete real accidents are the bigger circle, so we are covered with the regulations. That means the government laws will cover only the small area of the accidents. And using the NCAP tests, we can go bigger thing. Even you are getting the 5-star rating, you will cover only this much of the accidents. Only you can cover it. So there is a very big gap with the real accidents. So to reduce this gap between the NCAP tests and the real accidents, very, very large focus it should be there, and from the vehicles point of view and infrastructure point of view and all those things. So this is the where we need the advanced research should be required to reduce the fatalities. So from you can see the previous statistics from the 15,000 to 5,000 we can reduce drastically, but from there to reduce the zero it will be very difficult, right? So to reduce that gap, real accident database is required and more focus should be there on the vehicle reconstructions. So this is the vehicle reconstruction is nothing but, till now I told that statistical analysis of the accidents. In the vehicle accident reconstruction, we will come the scientific analysis, right? So here, this is the methodology how to reduce the fatalities and to generate the new safer car. So from the accident data analysis is the basic step. So this will cover both statistical analysis and scientific analysis. So if we have the data, then only we can analyze it and do the things. And NCAP tests and regulations. For all those to do this, to reduce the fatalities, we have already doing from the last 20-30 years. That is, there also the CA is very much required. But still, further accident reconstruction and car-to-car crash analysis, it will be the much more CA is required. So here accident reconstruction mostly we will do with the multi-body dynamics. That is not finite elements. But from the result of this accident reconstruction, we will feed into the finite element analysis. So these two are the scientific analysis of the accident data. So which are some of the configurations which will not cover in the NCAPs and regulations. That means they will do the most major configuration. That means frontal impacts, ODB impacts, oblique impacts also they will cover. So But in the real scenarios, we can't tell that only in this angle only accident will occur. So we have to identify those things using the accident reconstructions and car to car. These are the sensitive analysis. Each and every 5 degrees we will impact the car to car and we will analyze it. So these two things we have to implement. Nowadays, vehicle manufacturers also they are trying to implement beyond the NCAP tests. And here HBM means human body models. Instead of the dummies, complete human body models, they will introduce it. So this about these things and the Wednesday lecturer from the Satwin guy will detailedly they will explain it. So by combining these two, we can generate the next generation safer car. So as I told previously, only records. So for the scientific analysis, we require the different type of the data. So we have required the accident scene before accident. Before accident, how the vehicles will coming and which directions are coming and which point on the scene at the point of impact and the rest positions, and at the point of impact what are the angles vehicle is impacted and the rest positions in which angle it was there, and from the point of impact to rest position how much distance it is there. So all these details will be available in the accident database. It's complete accident scene will be there and the accident involved cars. So how much severity it was there. They will calculate how much in depth that deformation is occurred. So in India, these cars are available in the police stations, and outside India, US and UK, they have the maintained in some separate garages, and we can go there and we can collect it, all those details. If the side impact, they will take one reference point, and from there they will calculate the complete how much it was deformed, because all these things will require to validate the reconstruction. That means the reconstruction is nothing but we are reconstruct the real accident in the virtual, right? So for that we require the what is actually happened on the road. So all these details we will collect it, and which vehicles and how many events is occur, whether in a single impact it was occurred or double or triple impacts in the rollover impacts. So all those things, if sometimes 2 or 3 events also be happen, because front vehicle, if they have given sudden brake, the whatever the behind vehicle will hit the back side, and coming the 2-3 vehicles also they will hit it. Not only, there is no rule that only 2 vehicles is involved in each and every accident. So all those details, vehicle details, all things will they will collect in the accident database. So based upon this data, so we'll create in virtual cases. So this is the accident occurred in the Delhi. As in my research, MS research project, I have done these things because of the confidentiality of the data. So I can't show whatever they done in my company, right? So these are the details. This is the actual scene from the softwares. We have reconstructed the cases. So if you go through the IIT Delhi website, these details will also be available there also. So mainly we will validate these accidents. We will reconstruct the accidents. Then, because we will get the validation points at the rest positions also, right? So if your rest positions and angles and all those things is validated, then our complete vehicle accident is validated at the time of the point of impact. So by validating these data, and injuries of the data also. We will take the data at the time of the point of impact, because the same angle and same velocity they will hit the accident, then only this data will be the validated. So from this data, once we validated the final positions and angles of the vehicles, so at the time of the impact, just before the time of the impact, what are the vehicle velocities and vehicle kinematics and vehicle pulse. This data is very important to develop the new safer cars. That means any crucial critical accidents. So this data is very important to develop the further vehicles or resistance systems. And occupant kinematics and each body part pulse. These are the output data. We will take it from the validated reconstruction accident. So generally, this accident reconstruction till now means from the till last 10 years, it was used by the insurance clients and judicial purposes only. They were using before 10 years. Nowadays, all researchers and vehicle manufacturers are using this accident reconstruction to develop the safer vehicles. So these are the some of the reconstructions between the car to car and the car to heavy vehicle to know the vehicle kinematics, how their accident is occurred, and inside the vehicle how the occupant kinematics also be very important to reduce the injuries for the occupants. And so here the cyclists or motorbike people, how they are throwing distance and wrap around distance, all those things will matters to get the which level of injuries they will get it, and from the to improve their injuries levels, right? So all those things we can improve the to mitigate the fatalities. And between pedestrians and cyclists, all these things we can reconstruct the accidents, so to furtherly improve the to reduce the fatalities. So these are the real accidents, and if you don't have the databases, how can we do the things? So for that, from that point of view, some car-to-car crash analysis also be there. That means this is the sensitive analysis. We will model the both cars, not only single car. So compatibility of the cars for the between the opposite car will be the different vehicles, from the sedan to the SUVs and hatchbacks and minivans. All those things we will model the both vehicles, and we will analyze the situation. So like this 360 degrees sensitivity analysis, we will call it as, we will analyze the vehicles. So we will call it as a car to car. So without having the very critical databases are not available in India, right? So those things, in that situations, we will use this car to car crash analysis. So mainly the output is to improve the vehicle crash worthiness, to cover the worst cases other than the beyond the NCAP tests. So like this, we analyze. These are the kinematics of the occupants. So in internet, without dummies and human body models was there. So, but including the occupant kinematics and vehicle kinematics also we will analyze it. So from this, the conclusion is the improve the vehicle crash worthiness and can update the regulations and vehicle designs and road designs. So we can save at least fatalities. We can reduce it with the minor injuries, and we can reduce this. That is the object of the all this. So the conclusion points are the statistic analysis will give the what are the critical parameters and their ranges, causes of accidents, trends, risk levels of the injuries, and all these details it will give. It will very crucial for the policy makers and they improve the road infrastructure. And scientific analysis like accident reconstruction and car to car and injury prediction and their correlation with the actual injuries. This will very crucial for the automobile engineers, scientific analysis of the database to improve the vehicle crash worthiness, and we can suggest to the policy makers to improve the regulations and vehicle designs and injury risk curves, actual injury risk curves, we can get it. According to that, we can design the restraint systems and airbags and seat belts. So here this reconstruction data, you can use the, because this is the more advanced thing, because till now we are applying the only dummies. So we are introducing the human body models. That means each organs inside the human, each organ levels also they are model it. So according to this, in Wednesday session, they will cover it. So like this, validating human body models. So dummies means inside organs will not be available. Only the outermost parts are covered. Inside will be the different materials are available. So each and every organ level, even ribs, heart, lung, everything, diaphragm till diaphragm, liver, everything will be the model in the finite element. So this we will call it as a human body models. So these human body models are developed. Some of the only 5 or 6 complete human body models are available at right now. So for them, the dynamic targets and what are the injury levels target of the each and every organ, it is researching advanced topics. So according to these things, in Wednesday's session it will cover. So but for the reconstruction results, from there, what are the occupant kinematics are coming, that output will apply in the using the human body models, and whether it will be the how to mitigate the accidents. So this is the according to the CIE is apply where it will apply in the automotive safety. I cover only the according to the crash worthiness and the safety. So this is the where we can apply our finite element models, ANSYS or ABAQUS. ABAQUS is the dynamic analysis and ANSYS is the static analysis, right? So mostly dynamic analysis like ABAQUS, Dyna, Nastran, we will use it to analyze all the crash scenarios, whether it may be regulations or NCAPs or real accident situations. So this is the where we will apply our finite element models and basic engineering. So our next topic is the machine learning. Can we apply in our CIE? That means our analysis, crash safety. Can we apply the machine learning? Because the machine learning is mostly we will use to analyze the data kind of things, right? So, but as a scientific analysis, can we use this machine learning? So, as all of you as know, CIE will require the most so much of computationally powers are required, right? Most computational servers are required, and each and every object we have to convert into the finite elements, and then we have to apply so much of solver capacity is required. Computationally, it is more and more sources are required to do the CIE, right? So to reduce that, can't completely eliminate it, but we can reduce some of the computational resources by using the machine learning. So in Satwin we have done some concept machine learning, and nowadays we use in the complete full vehicle also. But today I will explain very briefly about the component level. Component level, how we will apply this machine learning in the CAE. So here we have taken the only crash can, that means which will be the absorbed energy in the accidents. That means whatever the crash impacts will come, these are the main parts to absorb the energy, so that forces will not go to the up to the occupant level. So in the main, I think all our automobile engineers, they know about the crash can, so why it is used it. So here we are. This is the setup CAE model. Some 16 kmph. We are impacting the crash can with the impactor of the size of the 100 into 100 into 200. The size. Some crash initiators also we have modeled it. So in this one, what are the thickness and materials of the crash can will change the energy absorption. All of us know, right? So if you change the thickness of the crush can and change the material of the crush can, the energy absorptions will be different, right? So for that thing, we have to model the complete crush can, and we have to assign this thing, and we have to do it. So as I am explaining in the component level, it might take the very less computational resources, but if you are coming to the complete full vehicle level, it will be the more comparatively more computational powers are required, right? So here, without CAE run, can we predict the energy absorption, that is the force values? Can we predict if the previous database is available, right? So here we can predict the force values for the new material and thickness. So whenever a new material and thickness, that line means nowadays materials, also the advanced materials are coming, composites are coming, and all those things are coming, right? So when we use the new material and thickness, what is the crush can absorb for energy absorption? That means force values using the machine learning without the CAE. So here we took the some 20 CAE runs data, input data. So that means 4 different thickness values, 0.8 to 1.4 range, and 5 different materials, material 1 to material 5. Using this small CAE data, so can we predict for the new material, that means M6 material for the 4 thicknesses. So without CAE run, can we predict it or not? By using the machine learning, we can predict it, right? So because of the data analysis, we can do it. So here this is mainly machine learnings, and these things will differ will be the, we will train the model with the not only input, we can give the corresponding output. That means M1 to 0.8, what is the force it is taken, and M1 to M1, how much remaining all thickness. That means 20 different CAE data, corresponding input to corresponding output. So using these two, we will tell to the machine learning model that, so if you have this material and this thickness, this much of force is required. So usually in the scientific analysis and any CAE software, we will only give the input. The output will be calculated according to stiffness calculations and number of laws, right? So using the input and output, we will train the machine learning model, and for the new material and thickness, it will give the remaining. So for the same material and thickness, what are the deformation patterns also we can give to the machine learning. So here these are the some comparatives we have developed in the SAT. We developed the one material machine learning model, and using the commercial software also we did the same problem using the commercial software. So we got the similar results with the commercial software, how that machine learning model and the commercial software is working. So similarly, SAT developed machine learning model also giving the similar results, and those are compared with the CAE results. So these are the black one are the CAE results, blue color are the SAT developed results. So for the new material with the 0.8, 1 and 1. And 1.4 thicknesses for the M6 material, so we predicted using the machine learning without CI. So, and we have also predicted the complete each and every element strains also be predicted, and the deformations also be predicted using the machine learning model without CI. So for the comparison purpose, we run the same input conditions, and we are compared it with the commercial software. Loaner results means some commercial software, and ML Python means Satman developed ML models. So like this, we can predict the complete deformation patterns, how where it was folded and where how much energy is absorbed, and deformation pattern, whether it is bending or crushing, and all those things also we can predict using the machine learning models. So here again, Satman developed model is in blue color, CI is in red, and the green color is the commercial software predicted results. So these are the deformation patterns, and these are the strain values. So this is the component level. We also predicted in the full vehicle levels. So that is the where we are. We can apply machine learning models in the CI. So that's all from my side. Thank you. If you have any questions, as I think I have took the same time.
Thank you so much, sir, for your
Thank
valuable
you.
information. Now I request any of the participants, if you having any doubts, you can ask. You can ask the this person. So all the participants, if you having any queries, you can post it in the comment box, or you can raise your hand and you can ask the queries.
Request all participants, please follow the rules, and while driving, be conscious and concentrate on driving. So we have to do from the engineer point of view, and we have to do on from the human point of view. Both, whenever we are keep our efforts, then only we can reduce the accidents and reduce the fatalities.
Yes, sir. I think there are no queries. No problem. So thank you very much, sir, for your valuable information, and I hope everyone has absorbed a lot of knowledge from you, sir. Thank you, sir.
Thank you.
You can leave the meeting, sir.